Hello, everybody, and thank you for joining us today for Vertica Unify 2021. This breakout session is entitled Introduction to Vertica Eon Accelerator Early Access. I'm Joy King, and I lead Vertica product and go-to-market strategy. I'll be your host for this breakout session. Joining me is Vishal Diman, product manager, and Sumit Kiswani, architect and software engineer for Eon Accelerator. But before we begin, I encourage you to submit questions during the virtual session. You don't have to wait. Just enter your question into the Q&A box on the right-hand side of the screen. There will be a Q&A session at the end of the presentation. We'll answer as many questions as possible during that time. Any questions that we don't address, we'll do our best to answer offline. Alternatively, visit the Virtual Developer Lounge to ask additional questions and continue the conversation with our engineers and product experts after the session. And yes, this virtual session is being recorded and will be available to view on demand this week. We'll send you a notification as soon as it's ready. Please stick around to the end of the session so you can get the code to gain points and participate in our Analyze to Win competition and win prizes. Now, let's get started. Over to you, Vishal and Sumit.
Thank you, Joy. My name is Vishal. I'm a senior product manager at Vertica. And today I'm very excited to present to everybody our Vertica's latest offering called Vertica Eon Accelerator. It is a fully managed service offering from Vertica. And currently we are in early access mode, and I'll be talking about that in future slides. So let's begin. At Vertica, we believe there will always be a space for a fully managed service or a self-managed or a direct managed service. And Vertica has always had a very good footprint in on-prem public clouds. And with a fully managed service, we want to really increase Vertica's footprint. So our latest offering is called Vertica Eon Accelerator. And as the name suggests, it's built on the Vertica Eon mode. We launched Vertica Eon mode more than 3 years ago, and customers have fallen in love with how performant it is and how scalable it is. So what we thought, why not use that as a baseline to start with? With Eon Accelerator, the advantage is that it will take minutes to provision and scale to your business needs. We also include some monitoring, and we will do all the upgrades for you. And currently, we are launching on AWS first, but we do intend to launch to other clouds. As you can see in bottom left of your screen, our USP is that Eon Accelerator runs in customer-provided cloud account. You can also think of it as a bring your own cloud account. What that means is, as a customer, you will link your own cloud to Vertica Management Plane's cloud, and the two clouds can talk to each other. And let me get into those details in a second. The advantage of this approach is that as a customer, you get complete control of your data and all the computing resources. So if you want to secure it, please go ahead. We will not come in the middle. Secondly, as a customer, you can negotiate your own infrastructure costs with your cloud vendor. Thirdly, there will not be any egress fees to transfer data out from your cloud. So there's cost saving for you. How this bring your own cloud thing works is that our management plane servers can directly talk to any computing resources that customers' cloud account will be having. All of this linking in Amazon speak is called cross-account IAM access. And this is established one time during onboarding. It takes about 30 minutes and it requires an AWS admin to help set this whole thing up. Nevertheless, this whole thing works through a simple web browser. So as a user, you'll be going to www.vertica.com/accelerator, and whole thing works through a simple interface. So to reiterate, imagine as a customer, your cloud is on the left side, and on the right side is Vertica's cloud. The two things are interlinked each other, represented by a purple double arrow, And this link in Amazon Speak is called cross-account IAM access, and this is established one time during onboarding. Now, as a user, you will go to vertica.com/accelerator, log in, and do all your actions, such as, suppose you want to create a database. These commands from the browser are sent to Vertica management plane, which in turn will be issuing commands to the customer's cloud and creating resources for you. To summarize, Vertica Eon Accelerator is different because you get to own your own data. There is no markup on hardware. We are able to use single tenant RESTful endpoints so that all your interactions are directly talking to the backend web services. And there's better total cost to ownership. And there's a good old Eon engine behind the scenes, which you customers have fallen in love with. So within Eon Accelerator, as a customer, you get to control start and stop for your databases. You get to control the scaling policies, such as schedule-based autoscaling or a fully elastic autoscaling. You get to choose the number of subclusters you want in your database. You get to choose the size and instance type of your subcluster. And you get to choose the incoming IP address rules for your database. Behind the scenes, the Vertica Eon Accelerator manages many things such as number of shards. We limit it to maximum number of subclusters to be 4. We limit to 1 primary subcluster. We manage, we monitor your services so that we can provide services such as uptime. We can provide support. We will do all the upgrades for you. We also limit the minimum and maximum number of nodes per subcluster to 3 and 12. And currently in Eon Accelerator, we support 4 kinds of EC2 instance types. The 4 instance types are i3 2x large, i3 4x large, i3 8x large, and i3 16x large. So we've kept things very simple here. So I thought the proof is in the pudding. So why don't I show you the actual product live? I'm very excited to show you this product video. Take a look yourself.
Vertica Eon Accelerator delivers blazing fast analytics as a managed service with a simplified experience for all. Setting up an account is quick, simple, and secure, with the possibility of enabling single sign-on in the future. After signing up, you'll cross-link Vertica Eon Accelerator with your AWS account. Our Bring Your Own Cloud model allows you to keep data and compute resources on your own secure cloud while leveraging your AWS pricing contract. Upon login, you'll be greeted by the homepage. Here, you can easily gauge your database's status and health at a glance, as well as view details on a more granular level. When it comes to creating a database, we've streamlined the process to maximize ease of use by offering popular, affordable, and highly performant choices. With simple cluster sizing and the option to scale up or down later, creating a database is quicker and easier than ever. While deploying your database relies on Amazon provisioning hardware, typically databases fully deploy in under 10 minutes. It's that fast. Adding subclusters is just as easy as creating a database. You can have heterogeneous subclusters within one database, each with different sizes and instance types. Since Vertica Eon Accelerator is running on Eon mode architecture, you can easily change your subcluster size and instance types with just a few clicks. Next, you'll follow a few quick steps to connect to third-party tools and your preferred programming language using the pre-filled connection string. DNS names are assigned to all your subclusters, so you can easily connect to them without having to memorize the node IP addresses. Now that your database is up and running, monitor the health of your entire system on a single dashboard. View the most relevant and important information about your system to get an indication of how well your databases are doing. There's also a similar dashboard where you can monitor usage consumption. This page shows a usage summary with session logs for each database, helping you monitor runtimes as well as manage costs. We know that our customers are busy people, so we're introducing autoscaling, a time-based scheduling feature that allows you to automate scaling on both one-time and recurring schedules. Alternatively, if you have unpredictable or volatile workloads, use elastic autoscaling. just set a threshold at which to start additional secondary subclusters at, and you're all set. In this instance, when a number of running sessions on the database exceeds 56 for 15 minutes or more, an additional secondary subcluster will start. More secondary subclusters will be started or stopped on the same basis. This, in conjunction with the flexibility of heterogeneous subclusters of different sizes and instance types, offers full control over the balance between performance and cost effortlessly. When you enable the idle shutdown feature, your database will automatically stop when there are no active queries running, saving you time and valuable resources. With that, we've covered the steps to get started with Vertica Eon Accelerator, as well as features to optimize for performance and cost, all with just a few clicks. Now you can have your analytics running on a Vertica database in no time.
Within Vertica Eon Accelerator, there are some key unique features. Let me get into some details here. Available today, even now, are features such as idle shutdown, DNS names for subclusters, elastic autoscaling, and event history. Let me provide some details. Idle shutdown feature came out of a personal need. At Vertica, during product testing, I would often create databases, do my testing, but forget to shut it down. This would keep the infrastructure cost running even when I'm not using the database. So we thought, why not have a switch where the system can detect no activity in the database and the system can shut it down for you. This will save you costs for both infrastructure as well as running Vertica. And as a user, no longer you have to hunt down the underlying IP addresses for all your subclusters. We provide a very easy to read and a simple DNS name for all the subclusters. And as you can see, the name pattern is on your screen. However, if you're using elastic autoscaling, the naming pattern slightly changes. And speaking of autoscaling, now we are very excited to introduce elastic autoscaling, where you don't have to control and sit around and scale your databases up and down manually, wake up in the middle of the night to turn off your databases or subclusters. When you enable autoscaling, the system can automatically scale your database based on your unpredictable workload. In this example, I have set up the policy so that when the system detects when the active running sessions increases by 56 for 15 continuous minutes, an extra subcluster is turned on. As you can see in my screen, there are 4 subclusters in my database. Each subcluster is i3-4x large with 12 nodes, but it doesn't have to be. In fact, I could have easily chosen my default subcluster to be much smaller, maybe having 3 nodes, and I could have chosen my subcluster 3 to be much larger instances. Nevertheless, when I turn on this policy, when the system detects, say for the sake of discussion, the number of active running sessions is 50. Since 50 falls in the range of 0 to 56, only the default subcluster will be turned on and rest of the subclusters will be turned off. Now suppose the active running session increases to 100. Now 100 falls in the second column. That means the subcluster 1 is turned on, and now every subsequent request is round robin between default subcluster and subcluster 1. So that will offload some of the workload from default subcluster and really give you better performance. Similarly, if the number of active running sessions say increase to 150, the subcluster 2 is turned on, and say it increases to 200 or above, subcluster 3 and all 4 subclusters are turned on, and all the requests are round robin between all the subclusters. And the inverse is also true. The system can cool your database down too. So suppose your number of active running sessions dramatically decreases, say from 250 to just 50, the system will turn on all the extra subclusters so that only the default subcluster is running. And with Eon Accelerator, we are introducing a new feature where you can see the event log for all the database subclusters turning on and off activity. So you can see when a user or the auto-scaling policies that are turning on your databases or your subclusters. It's a very easy to view screen where you can have filtering and sorting capabilities. And Eon Accelerator is currently in early access mode. What that means is during this early access program, there's a special offer we are providing for our customers during this time. So it's a great time to sign up. Currently, there is no Vertica fee for trying out our Vertica Eon Accelerator product. Do keep in mind that customers will still need to pay for an AWS bill. However, at Vertica, we are not charging any fee for during this early access trial period. We encourage you to try your production workload. However, keep in mind, currently there is no live triaging yet. We are working very hard towards providing this, and this will be available very soon in the future. Currently, all the features are available to you, such as elastic autoscaling, minutes to scale and provision. All those features are available to you, except with following guidelines. For each account, we limit to 5 databases per account, and we limit each databases to have up to 4 subclusters, 1 primary and 3 secondary subclusters. Also, we are working very hard and adding new features all the time. So there will be some periodic software updates. We want to keep the downtime to the minimum, so we will be reaching out to you and make sure planning with you to make sure the downtimes are minimized. And lastly, the Vertica team will reach out for feedback. This is your way to have a say in the roadmap and influence our roadmap. Again, to reiterate, what do you pay right now? There is no Vertica fee as of right now in the early access mode. However, customers still have to pay for the infrastructure cost. And to get started, all you need to do is bring your own AWS account. And you will also need help from your AWS admin to set up this cross-account IAM access. And where is your data? The data is staying within customers' own AWS account. And what are customers benefiting from Eon Accelerator offering? Services such as uptime, easy orchestration, very quick deployment, monitoring, idle shutdown, full auto-scaling, and scheduling features. Now, Sumit Keswani will be talking in more details about architecture and underlying details of Vertica Eon Accelerator. So over to you, Sumit.
Thank you, Vishal. Hello, everyone. My name is Sumit Keswani, and I am an engineering manager at Vertica, and I have been primarily involved with Vertica Eon Accelerator in the last year. So today I will be dwelling deeper into the underlying architecture of the solution that we have, with a goal to to show you what the inner services are, how they are laid out, and finally I will go over a couple of use cases of how a user's request flows through the system. So let's get started. So the first thing you will encounter when you start to use Vertica Eon Accelerator is the onboarding process. The onboarding process, as Vishal mentioned, is the act of connecting a customer or your cloud account with the Vertica management plane. This takes about 30 minutes to do, and it's a one-time task done initially, and it requires that you have the admin access to your AWS account. I have laid out a little schematic here to show you what happens. Basically, you come to us with your AWS account, and this request goes through the web interface, which you will be interacting with. And once this request goes through, we create a AWS IAM role in the Vertica management plane to represent your account. And we respond to you by giving you a simple script. We call it the CloudForm. We use a CloudFormation template. It's essentially just a simple script that the customer or the user will have to take to your AWS account and run it as an administrator. What the script does is it creates a corresponding user in your account, in your AWS account, and creates a one-way trust between a user in the Vertica account and the customer's account. This is very similar to a federated access or Kerberos or SAML access that you are familiar with, no passwords or no keys are involved. These two users get linked, and after the linking is done, commands can be issued from the Vertica management plane into your AWS account, and you can actually see us making those commands. You can audit and track those commands. And the idea is that we create a one-way trust between the two accounts so that we can manage the Vertica database in the customer's account. So once this process is done, just one time for every AWS account, we are off to the races. At this point we can do pretty much anything we need in terms of managing your Vertica database in your account. Now, the second piece of the architecture is the front end. The front end is a web UI which is hosted in AWS. It's a very simple React.js based single page app running in a Docker container. It's a multi-tenant web app. It's configured with failover behind an application load balancer. It is set to autoscale, and we use Okta single sign-on, which is very simple Java token technology for authentication. It's a pretty simple industry standard design for making web applications. The web application is a very thin and restful layer sitting in front, and its main goal is to authenticate the user, figure out where they're coming from, and pass them to the backend. The backend is an agent which is going to act on behalf, is going to act on your request on behalf of the users that you just created. So let's go into the backend architecture. The backend is actually a single tenant REST API agent. We also call it the orchestration agent or the OA. This agent there is one agent per customer. So this piece of the puzzle is single tenant. The reason it is single tenant is that it is more secure. Every customer gets their own agent so that there is no cross stock. There is no noisy neighbor effect. If one user or one customer is running a very heavy workload or doing a lot of things, the other customers are unaffected by it. And there is no confused deputy problem where if there is if there's a bug or a mistaken identity, the action gets executed on a different account. An agent is single tenant, and therefore there are no commands being run on the agent that are not issued by the corresponding customer. So this is essentially our way of ensuring capability-based security. The agent is not capable of issuing commands to any other customer. It is only dedicated for this one customer, and it can only work on behalf of that customer. And this is ensured by making sure that the agent is running with the IAM profile of the trusted user that was created. So any other command essentially would fail that does not belong to this customer. So this, the highlighted part in the square is entirely a single tenant process. So once you're past the front door of the web UI, all your actions are single tenant. And as I said, this is to ensure the best security and isolation. Here's another picture. In this, I'm going a little bit deeper to explain that when an action is executed, the Vertica agent makes a call directly to AWS using cross-account IAM access through the AWS API to provision resources directly in your cloud. So we can create instances, stop and start instances, and provision any infrastructure resources that we need directly on your behalf by talking to the AWS API gateway. After we provision the resources, we have to actually connect to the Vertica database and add those resources into the cluster so that you can use them. This is done by using a simple HTTPS call over a firewalled connection over port 5444. Basically, this is the Vertica agent call. We ensure that we have an IP whitelist, so there's a firewall protecting this connection to ensure that connections are only accepted from our management plane. And we ensure that we have mutual TLS on this connection, so there is non-repudiation, and the wire traffic is encrypted. So going even deeper into the backend or the agent, which is the heart of our system, what is it made up of? So it runs three different services on there. We run Terraform on there to essentially provision resources. Terraform is becoming an industry-wide standard for provisioning resources in the cloud. It's multi-cloud, it's idempotent. It can detect drift and correct the drift. So, if your target infrastructure deviates from what we want it to be, we can detect it and correct it. It's easy to use and build, and it saves your infrastructure as code. So we basically define the infrastructure that we are running, and we maintain it using Terraform. So that's one big component of our system. We do not have any passwords or credentials that we store on the orchestration agent. As I said, we use the cross-account IAM instance profile. So we follow Amazon's best practices, where the trust is rotated ever so often, and it's done through the API gateway. So we do not store any keys. The connection that is made over HTTPS to the Vertica cluster is, of course, it's SSL, it's mutual TLS, it's encrypted, and we try to make sure that it's as secure as we can get it. The final piece of the puzzle is how the customer or the user, the end user, accesses the database. So the end user access to the database is over port 5433, just as you are currently are used to using or have been currently using. A customer decides where their clients can come from. So you basically define a source IP of your clients, and we restrict connections into the database from that source IP. So you can put your Office IP or your VPN IP, and we will only accept connections from those IPs and reject connections from elsewhere. So you get that level of security. Beyond that, you can create and define non-privileged users and grant them specific access to tables using database grants. If you're a DBA, you're probably familiar with doing that. There's no change in process there. One important aspect to note here is that access to the database is direct. There are no proxies or VPNs sitting in the middle, and the idea was to give you the best latency and performance characteristics as possible. So we do not put something in the middle to meter calls. They go directly into your database. And as a convenience, we actually map a DNS name to the IPs of the various nodes of the cluster. So you don't have to remember IPs and keep track of them, because they can occasionally change. As long as you use the DNS name, we'll manage the IP to DNS mapping on the internet. So that's just a convenience feature to make things just more usable. So putting it all together, I have kind of merged all the pictures I showed you so far. You can see this is the overall architecture. We have on the right-hand side a customer coming in through the web UI, gets authenticated with Okta, goes through the web portal, and after that the traffic splits. There are different agents for Alpha Corp and Beta Corp, which are two customers, and they're both agents managing independent customers, and there is single tenancy there. And finally, on the left-hand side, a user can connect to the database directly. We do not proxy that connection to ensure the performance and latency that you are accustomed to when using Vertica is maintained. Okay, so having given you a bird's eye view of how the architecture looks like, let's go through a couple of use cases. So a very simple use case is, say you want to size the Vertica cluster. You may want to add some nodes or increase the capacity. Here's how the information will flow through the entire system. As a user on the right-hand side, you will authenticate into the web UI, and your request to increase the cluster size will be relayed to the agent, the orchestration agent, which would then issue a command to the Amazon AWS API gateway through the cross-account IAM instance profile to create more database nodes. Once those nodes have been provisioned and we get a response from the API gateway, we will then issue a command over HTTPS across to your Vertica cluster on port 5444. And this command would add those resources into your database, and you will get extra capacity. This process will go through pretty seamlessly. You will not know that this is what happened in the backend. The UI is all you will interact with. So here's the simple UI. representation of what I just mentioned. You can, add a subcluster, resize it, edit instance types. So if you need more workload isolation, if you need to add or remove a subcluster, you simply have to, work through this UI to do it. You need bigger or smaller instances, you can edit the instance type. If you need more CPU power, you can add more nodes by resizing a subcluster, and all of this occurs, using the process that I just mentioned. Okay, let's go through another workflow. This is an auto-scaling workflow. And here, it's very similar to the prior workflow we mentioned, except there is no user in the loop. The agent, the orchestration agent, is running a service which is monitoring the performance of the database every 5 minutes. So we monitor, what queries are running, how many users are logged in, and we maintain an active count. And if we realize that the database load is too high, we can scale up and start more subclusters. Alternatively, if we realize that the database is not being used, we can, or if it's idle, we can shut it down. We can also look for anomalies, like a node not functioning right or is not running where it should be running, or if there's an outage, and we can automatically notify Vertica support that there is, some sort of impairment or problem occurring with the cluster that needs to be looked at. So here is pretty much a daemon style process where there is no user in the loop, and we're just monitoring using services. Yeah, so and here's a UI that you will use to interact with the auto-scaling and monitoring piece. Vishal mentioned this in detail, so I won't spend too much time on it. But we can use this mechanism to start and stop subclusters. If the database is idle, we will stop it, and we can also notify support in case something is underperforming or not performing correctly. Here's a final use case about charts and telemetry. So one of the things we did in Vertica Eon Accelerator is we realized that Vertica process monitors the underlying infrastructure pretty closely. The Vertica database monitors memory and CPU almost continuously. So what we decided to do is that we changed the Vertica process to send this information into S3 and just save it in a storage location in Amazon. And the orchestration agent, as a result of the cross-account IAM call, can get access to this information directly. And the reason we did that is because we wanted to make sure that you have access to telemetry data and activity data without actually having to keep the cluster running. So in Vertica Eon Accelerator, you can see your database information, host and node performance metrics, even when the database is turned off. That's because every time this data was collected, it was uploaded to S3 so that it is available to the orchestration agent for reporting. We haven't spent too much time building very detailed reports, but we are able to correlate user activity and host activity in the same manner because we are capturing it through the process. So you can correlate user activity with host activity. And the idea being is you would be able to tell which user is consuming more resources and which user is consuming less resources. And here's an example of some charts that you could see. These show you memory and CPU usage. At the bottom, you can see which users were active. At the top, you can see what queries were run. So you can put these all on the same timeline. And the reason is that we use Vertica itself for giving us telemetry data, and we save it off to an offline storage where it can be accessed at any time. Okay, so now I will spend a few minutes on telling you what we will be working on in the future. These are some upcoming features. We will be adding more capability to survive failures in the cloud. Partial outages that may occur in cloud vendors, we will be working to mitigate them. We will be adding incremental backup and storage here, so you can back up specific objects and restore them in a snapshotting manner. We will be adding migrations from different databases into Vertica Eon Accelerator, from on-prem systems to cloud systems, and for enterprise systems to Eon systems. So a different series of migrations will be added. Over time, we will add support for data pipelines, loading from S3 or other stream like Kafka or other sources. We will add a web SQL editor, and we may add a bunch of other ecosystem integrations by working with our partners to enable different use cases there. So with this, over to you, Joy. Thank you very much.
Okay. So thank you, and this is a very exciting time. Want to for Vertica and Vertica Eon Accelerator. So first, Vishal, a question for you that I hope you will find fun to answer. Why did you decide to run the Vertica database in the customer-provided cloud account versus as a bundle like many competitors do?
Yes, thank you for the question. We were researching this, and while doing our research, we found out that, first of all, we don't want to mark up the hardware. So we realized that many of our customers have very strong negotiating powers with their cloud provider. So we did not want to come in the middle. Secondly, we also realized many customers have they can use the committed spends, so that can really give them discounts on their infrastructure costs. And lastly, there will not be any egress fees for them to offload their data from their cloud to somewhere else. Everything is sitting in the customer's provided cloud account. So those were my reasons. Sumit, do you want to add anything here?
I think you answered it accurately, Vishal. A big reason was, if you have committed spend with your cloud vendor, this will apply towards that, and you can leverage the negotiating power of that committed spend.
And Sumit, as a follow-on for you, this is an important question based on the architecture of Eon Accelerator. Can Vertica's cloud account access any customer data? Does it have any privileges that can compromise the security of the customer's database?
Oh, this to a great extent, right? We are running in the customer's cloud account. We do not have access to all of customers' data. We explicitly will ask you for the names of the buckets. We'll ask you for a bucket prefix, and we will create S3 buckets with that prefix only. We will not take access to anything else besides those specific S3 locations. So when we set up the cross account IAM linkage, you can see the permissions that we get, and they are very specific to very targeted buckets that will be used for the communal storage for the Eon database and nothing else. So no.
Okay, so that's a very important distinction as well in terms of not having to move data into a third-party platform, even if it's on AWS.
Yep.
Okay, so Vishal, as the product manager, not just for Eon Accelerator, but also for Vertica's Management Console, this question was designed for you. Does Eon Accelerator also spin up automatically, manually, and configure the Vertica Management Console when creating a cluster?
I knew that question was coming. The answer is no, because in a fully managed service, we want you to use our Eon Accelerator UI. We have spent a lot of time rebuilding this UI. I really like it. We made it very simple to use. And if there's something in the UI or any feature that you think would be very useful to you or something you miss from Management Console, please reach out to your representative and they'll reach out to me eventually and we can get on a call and we can discuss this.
Okay, so now here's a question for you, Sumit, and this is, I think you actually addressed it in the session, but that could be me not understanding. Can Eon Accelerator auto-scaling be based only upon CPU or other resource usage other than session counts? So looking at what kind of criteria can auto-scaling be based on?
So as of now, it is based on session count, active session count actually, to be very precise.
Okay.
But yes, we can base it on CPU. That's not the current functionality. Nothing really prevents us from doing it. I mean, we are tracking CPU and we are tracking memory and a host of other things. We thought this would be the most relevant metric. As time goes by, and if CPU turns out to be something that people want to autoscale by, we can definitely add it. In our experience, high usage of CPU, is typically someone running a bad query, and you don't want to give them more. But it's not hard to do. It's just a matter of putting in one more schema in there that tracks it, that autoscales with that variable. So not currently, but can be added fairly trivially.
Okay, and this is good feedback, by the way, for anyone that is joining the early access program and says, well, here's a use case where I would use this, I would need this. That's exactly what both Vishal and Sumit and team would like to hear. So also to reinforce, and maybe you guys want to make a comment here, it was called out in the video, but you have both auto-scaling and auto-scheduling, right?
Correct.
That was a good
Yes.
unanimous thing. What's the difference? What's the difference between auto-scheduling and elastic or auto-scaling? So Vishal, I'll get you to answer that, and then I have a list of technical questions, even more technical, for Sumit.
So thank you, Joy, for that question. For auto scheduling, if you know in advance your workload and you can predict your workload, for example, a typical use case I always hear is my analytics team only works from Monday to Friday between 9 a.m. to 5 p.m. Maybe it's your data science team. Well, you can create a subcluster in your database for that, and then you can only turn it on. So you can schedule it to turn it on at 9 a.m. and then you can schedule it to turn it off every day at 5 p.m. So you're only paying for the infrastructure cost during those periods. So that's when you can use auto scheduling. Elastic auto scaling, however, is designed that if you have very volatile and unpredictable workload, then the system can just scale up and down for you, and you don't have to wait. You don't have to do anything. It's auto magical almost. Like Sumit said, it's based upon active running sessions. And as your sessions increase, it starts turning on more and more infrastructure for you. And as your sessions decrease, it lowers it down for you. So that's how it's designed for.
Okay. All right. So now, Sumit, over to you on a question about REST APIs. Does Eon Accelerator provide REST APIs to implement automation of scaling, database creation, etc.?
So currently, we do not expose a REST API. We do have one. We did not expose it because it's a little bit early. We want to get some feedback. As the solution matures, we will definitely expose a CLI or a REST API where people can perform some of these tasks, script some of these tasks. One of the logic or one of the reasons behind this was, we provide a lot of tools and tooling to do exactly what you would script, right? Like auto scaling and schedule-based scaling and idle timeout. So this is the kind of stuff you would script anyways. So we do provide that, and the hope was that let's field test these, and then we'll develop them further or make them more mature. So short answer: there is no REST API exposed at this point, but there is one that can be exposed in the short term, in the medium term.
Right, in the medium term. So now, Vishal, this is a question that's actually really a layup to early access. It says, would it make sense to test the Eon Accelerator with the Community Edition of Vertica on AWS?
So right now, you don't even need Community Edition because it's totally free for you to try. So I wouldn't do that. Just go ahead, sign up on vertica.com/accelerator. It's free to try for now. We will be GAing this at some point and we'll be announcing more details about that. But until then, please try it out and give us feedback.
Right, and I think I will take the liberty of saying those early access users who give us positive feedback, we will definitely be looking at collaboration on extending your contracts when we do go commercially available. And that was just a subtle hint too. We care about our early access participants. Now, two other PM related questions, Vishal, which we know are important and certainly important to me. When do you expect to start rolling out to GCP, Azure? and what's your vision for where this is going overall?
Yes, thank you, Joy. So right now we are launching in AWS first, and we really want to battle test our product, really get it very, really make sure this is working, the UI is working, all the features that our customers need are there, and absolutely we want to roll out to other clouds right after. Which cloud to go after next, whether it's Azure, whether it's GCP. If I'd love to hear from our customers. Please reach out to us and tell me. We are thinking in a certain direction, but we are definitely open to changing our minds here. So tell us.
Yeah. Absolutely. So that's really good feedback. And, in terms of, I'd like to get both of your perspectives on this next question. They'll be related, but slightly different angles of perspective. So Sumit, I'm going to start with you. When should a client consider using Eon Accelerator? What's the criteria? How would you define, because one of the greatest advantages that Vertica is bringing is this is not just, Vertica is now only as a service, right? It's Vertica as a license, Vertica as a service. We have both. We'll continue to have both. When do you recommend that a customer consider Vertica as a service, meaning Eon Accelerator, versus managing that deployment on their own?
So the biggest benefit of using Vertica Eon Accelerator would be the time, the effort, and the cost you would having either a DBA or a DevOps engineer monitoring and managing a cluster, and speaking to support and working through a bunch of other things. So the saving is in terms of the amount of effort and time required, that you don't want to spend, and you would save that. So you may have these big clusters that are used for your production workloads, and you're managing them, and you get these other requests from smaller or users saying, could you provision another cluster for us? Could you create a dev cluster for me? Could you build a staging cluster for me? Could you set up a cluster in a different region that looks identical to this one? These are kind of, they are clusters that you want to give them, give your users, but you don't have the time and the bandwidth to do that. So Eon Accelerator is a good use case there. You don't have to go out, hire DevOps people, or add to their workload. You can just use the service. So that's, I think, the biggest win for using Vertica Eon Accelerator.
So what's your take on that, Vishal? Especially, yeah. Go ahead.
Yeah, I wanted to add a couple of points, right? So there will always be a space for self-managed or a licensed version versus an as a service. So we want to tackle both. In fact, I can imagine a customer who does both, because what I'm learning is that data is growing tremendously fast in the customer's location, and their resources, technical resources, whether DevOps, whether DBA, there's only so many resources you can have. There's lots of POCs happening, lots of this data science projects I keep hearing about. So why not have both? So I think there is room for both, and customers are free to choose which one applies to them in their use cases.
So that's a very important point, again, because we have so many of our current customers that are looking for and, not or, right? They need Vertica for hands-on control, optimizations, tunings, all the things that they want to do, but they also, to Sumit's point, have needs for as a managed service for certain use cases as well. So absolutely, that makes perfect sense to me. And I think the final question in the short amount of time that we would have left is probably for you, Vishal, to start, but Sumit, I think you can make your comment too. Do you envision Vertica having a bundled hosted offering in the future, including the hardware on a variety of platforms?
Actually, Sumit, why don't you take that one? I know you have strong opinion about this one.
I don't know definitively, but why not, right? I mean, we want to grow in different spaces. We already work on multiple clouds, multiple hardware vendors, including storage vendors. So yeah, I think so. I mean, I think we'll get there. It may be a longer term journey, but yes.
Well, I think it's true to our vision that Vertica offers so many choices because we want to satisfy everybody. We're very good at that. Multiple clouds, on premises, as a service, directly managed, hosted, on your own AWS account. We do listen to a lot of requests. Makes it a little bit tricky for R&D every now and then, but hey, they always want to get better and better, so that's not a problem. So we have now reached the end of Q&A. I do encourage everybody who has more thoughts, discussions, or you might want to ask more questions, drop into the Dev Lounge. You can talk to them and challenge them directly. I promise you, there's no question they won't try to tackle without a doubt. Now, in addition, please remember to enter the code for this session into your Analyze to Win platform. The code for this session is Yorkie. And remember, every point you earn makes a difference in a dog's life. And now I'd like to share a short video from one of our sponsors, Good Data.
Do you want to make self-service analytics an inherent part of your software product? With Good Data, you will launch in just 8 weeks, serving hundreds or thousands of customers with a return of $4 for every dollar invested.